Welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. Today's session is specially for my grade 9 elite math students. And for term 3, the lesson that we are looking at today is lesson 12.5, Completing the Squares. This is a very useful topic of factorization where you complete the squares, and in today's session the learning objective is to solve quadratic equations by completing their squares. This video is going to be very useful for all my grade 9 elite students, and this is going to be also useful for my grade 10 elite students where they will learn and revise and recall the method of completing the square. Method. First of all, what is this completing the squares method? Let's get to know. It's a process that is used to make a quadratic expression into a perfect square trinomial. So a quadratic expression will be given to you. So quadratic means its degree will be 2, and it has to be converted into a perfect square trinomial. So trinomial means it will have 3 terms, number of terms, and perfect square means either it can be of the form a plus b whole square or a minus b whole square. So these are perfect square trinomials. So that's our objective here, to complete the square. This video is very important, so make sure you watch it till the end so that you learn this method nicely, and then you can use it for both grade 9 and 10 for solving problems. Okay, so let's understand the key concept. This is pretty important. So there are going to be 3 steps, step 1, 2, and 3, that you'll follow for any question that you get on completing the square. So this is valid for a quadratic equation of the form x square plus bx. So what is b here? B is the coefficient of x. So whatever number do you see along with the sign, that will be b. So in step 1 you find 1/2 of b, which is the coefficient of x. So 1/2 of b means you divide b by 2. Then you square the result in this next step. So b by 2 whole square, that's what you do, and then you add the result to the question. So x square plus bx, you add to this b by 2 whole square. So this is now a perfect square trinomial, and you can check that. Add the terms. Let's change color and count. 1, 2, 3. So there are 3 terms. Yes, it's a trinomial, and it is equal to this form x plus b by 2 whole square, which is a perfect square. So yes, we have successfully converted into a perfect square trinomial. So that is the 3 step you will follow for completing the square method. Let's take a question and solve it and apply these 3 steps to complete the solution. So first I'm taking a solved example. I will explain this to you and then we'll do one question together. So find the value of c that makes x square plus 16x plus c a perfect square. So if you compare ax square plus bx plus c, this is the standard form of a quadratic function, so or a quadratic equation. So standard form of, why it's quadratic? Because the degree is 1. Quadratic function, let's take it as a function. So here the coefficient of x is important, so the value of b is 16. So let's do step 1, find 1/2 of b. So divide by 2, 8, square of 8 is 64. Add the result to the question part. So you add this to 64. Now is this a perfect square trinomial? Let's check. This is x square, already perfect. 64 is 8 square plus 2 times a times b. So the first term is x, the second term is 8. Yes, so this is coming out to be 8 x plus 8 whole square. So which identity we used? A plus b whole square is equal to first term square plus 2 times ab plus second term square. So in this problem, if you see, the first term is x, the second term is 8. So you used algebra, you used this identity along with the 3 steps to complete the square. So the value of c that makes it a perfect square is 64, and the perfect square trinomial can be written as x plus 8 whole square. Okay, so if you've understood that method, let's solve this here. So first we compare with the standard form and get your value of b. So b is -14. Step 1. Step 1 is to divide b by 2. So b divided by 2 means negative 14 divided by 2. So that's negative 7. Step 2 is to take its square. So b by 2 whole square means negative 7 square, which is 49. Step 3, you add this term to the given question. So x square minus 4x plus 49. So that means the value of c that makes this identity a perfect square is 49. So c part is c value is 49. Now we need to write the trinomial as a perfect square. So now let's try to factor this. So first term square, second term square minus 2 times a times b. So which identity? Yes, you are right. Here, because of the negative sign, the identity that we have used is a minus b whole square. We are going back to algebra and it is expansion as this. So in this problem, a, the first term was x, b, the second term was 7. So answer is this. This is the perfect square trinomial. So I hope you have understood this method nicely. Okay, so let's now solve the equation by completing the square. So the difference that you see here is now you have equal to 0. That makes it an equation, quadratic equation. However, the method, the 3 steps you saw to complete the square will remain the same. The only difference in this question would be we will first write it in x square plus bx form, and then we'll move this negative 11 to the other side, making it positive 11. Now how much is b here? B is the coefficient of x, so b is 10. So b divided by 2, next step is 5, and its square is 25. That means 25 is the number that will be added to both sides. Now in this case, because it's a quadratic equation, we are going to add 25 on both sides of the equation so that the equal to is not changed. Now combine a square plus b square plus 2ab gives you x plus 5 whole square equal to 36. Now we are going to use the square root property to take the positive square root, and this comes out to be x plus 5 equal to plus minus 6. Now when I say x plus 5 is equal to plus minus 6, now being a quadratic equation, it will have two roots, two solutions or two factors. So I can break this into parts. X plus 5 is plus 6, x plus 5 is minus 6, and accordingly I can get the two solutions as 1 and minus 11. So therefore these are the two solutions, and you can check your result by factoring. Perfect. So let's do one more question. Now we're going to try this in the notebook. Everyone do it with me. This is homework for you. So step 1, we are going to move this 24 on other side. So it becomes negative 24. Now the value of b, let's change color and write on the top. B is negative 10. So b divided by 2 is negative 5. Then you take b by 2 whole square, so it will be plus 25. So I add 25 here and I add 25 here. So what does this give you? This gives you x square plus 5 square minus 2 times x times 5, and here 25 minus 24 is 1. So now you get the perfect square, x minus 5 whole square equal to 1. So now I'm going to write this by taking the square root property. So when you take square root of both sides, here also, it will give you plus minus 1. So these are the two roots. We can break them as x minus 5 equal to plus 1 and x minus 5 to minus 1. So here x is 6, here x is 4. So the two roots are x equal to 6 and x equal to 4. You can check your answer. In a similar way, I want you to solve question 4b as your homework in your notebooks, and these are the solution to check your answer. Okay, now let's consider another case. Here is the case where the quadratic equation does not have the value of a as 1. So what is a? Let's recall ax square plus bx plus c equal to 0. This is the standard form of a quadratic equation. Now in the standard form, if your a is not 1, like this case, a is 2, what do? Will the method change? Let's see. So again, we are going to do this method of completing the square because a is 2 and we are used to having a as 1. So we are going to divide the whole equation by 2. So when we divide the whole equation by 2, this is what you get. Now let's look at the value of b. How much is b? B is negative 7 by 2. So what will be b divided by 2? It will be negative 7 over 4 and then you have to take its square. So the square will come out to be 49 divided by 16, which will be added to both sides, and again you move this term here to make it negative. So till now if you see, the method is same. The only difference is we just added one step of dividing by 2 so that the coefficient or value of a could become 1 like the last case. Now you get the perfect square. Perfect square is a square plus b square. So b is 7 by 4 with the negative sign. So a minus b whole square identity is applied. And now that you have square, you can use the square root property to take the positive square root and the negative square root. So you have two roots. One is 7 by 4 plus 3 by 4. One is 7 by 4 minus 3 by 4. So one root in the solution set is fraction 5 divided by 2, another is 1. So as you see, the method of completing the square did not change, but just one step got added where you divided to make the coefficient 1. Notebook should be out. You should be working the question out with me. This is the classwork question. This one you'll try at home yourself. So let's discuss for this part here what is the value. If I compare ax square plus bx plus c, the value of a is 3, which is not 1. So we will divide by 3 the whole equation so that a is now 1, b is 10 by 3 and c is negative 8 by 3. So what is the value of b? Let's do the three steps. B is 10 by 3. So b divided by 2 is 10 by 3 divided by 2, which is 10 by 6. So b by 2 whole square, last step, is 10 by 6 whole square, which is 100 over 36. So this is the number. I'll just put this in a corner. This is the number that needs to be added and subtracted to both sides. So I take x square plus 10 by 3x on one side. We move this on the other side, so it becomes positive. Now we add 100 by 36 here and we add 100 by 36 here. Let's see what simplification we get. We get x square plus 2 times a times b times x plus 10 by 6 whole square. So now we are getting a perfect square trinomial on the left, and on the right I can reduce this. Let's divide by 2 these terms just to simplify it up, so it becomes 50 over 18. I can still divide by 2. It becomes 25 over 9, okay, plus 8 over 3. So I'll have to take LCM so that I make the denominator same. So it is 25 plus 8 threes are 24. So this gives you 49 over 9 on the right side. So now let's just due to lack of space, I have to now go up. So this term will give you a square plus b square plus 2ab. So this is same as x plus 10 by 6 whole square. So I'm going to write it here now. And on the right, you have got 49 over 9. 49 over 9. This value, which is again the perfect square of 49 is the perfect square of 7. This is perfect square of 3. So you can write like this. Okay, now you take the positive square root here, square root here, square root property. So x plus 10 by 6 will come out to be two options. One is 7 by 3, one is positive, one is negative. So I'm going to change the sign here. Okay, so one root is x equal to minus 10 by 6 plus 7 by 3, and another is minus 10 by 6 minus 7 by 3. So again, you'll take LCM, simplify, and your roots will come out to be -4 and 2 by 3. So it's a little long question, but the method to solve is same. I hope you have understood completing the square method. Do try question 5D in your notebook and check your answers. So that brings us to the end of today's session. Thank you for watching. I hope you found the video useful, and if you did, please press that thumb icon and press the bell icon to receive notification of all my upcoming videos. Don't forget to subscribe to the channel, and if you have any questions and queries, or you want me to make more videos for you, let me know your suggestions and concerns in the comment section. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.